Our big micro-world is compounded by various technological inventions on a daily basis, and in this day and an age of high-tech, we all must surf on the crest of the IT mainstream wave to learn some new tricks of the trade that help us solve everyday problems. Computers to the rescue, but many of us are not always able to quickly solve many problems that may arise. For this, cyberneticists around the world are constantly trying to speed up the processing of large volumes of information. In line with this task, a true supercomputer was created. Simply put, IT geniuses integrated many conventional computer processors into one system. In essence, computers are standard machines familiar to us, but they are used in an unorthodox way. The first unusual aspect of a computer is that we do not work with it interactively, as we are accustomed to working in a graphical user interface (GUI) regime, based on an agglomeration of some small windows. That would not be rational, since every minute of work with a supercomputer is rather expensive. In many industries, qualitative development requires handling massive amounts of data. For example, without supercomputers, it would not be possible to decipher human DNA, find out which of the hundreds of thousands of new substances could one day become the medicine of the future, test whether a 100-floor building would stand, or even calculate whether a spacecraft could reach Mars. After all, there are more down-to-earth tasks. For example, forecasts of economic growth are also a problem with their many variables and inaccuracies. It would seem that it is as simple as putting several dozen computers next to each other and letting them work. What is so special about that? But the fact is, they would not simply work together, as that requires special software and knowledge of how to hook up and program the computers properly. Therefore, supercomputers can only function properly with professional cyberneticists at the helm of this branch of modern technology of the highest level. Ukraine is one of those countries that produces some of the best high-tech cybernetics specialists in the world. This is evidenced by at least the fact that the first computer in continental Europe was created in Kiev as far back as 1951. What is our institute traditionally renowned for around the world? It is highly acclaimed for its works that are fundamental in nature, which forms the basis of the development of modern-day computer technologies. They include mathematical modeling of complex processes in different spheres of strategic importance, such as biology, economics, and certain other social sciences. Ukrainian scientists are not only theoreticians. The supercomputer created at the Institute of Cybernetics confirms this fact. Even its nickname is rather impressive and intriguing: SCIT, Supercomputer Cybernetics Institute of Technology. More precisely, it is not a supercomputer, but a supercomputer complex, seeing as several of these machines are combined in it, mainly SCIT-3 and SCIT-4, which today are fully functional. Its nodes and processors are always staying busy, but according to its developers, one of the main problems is managing the queue. It is not like a counter in a shop. When you come up, pay for something, and leave the store. To use the supercomputer, you have to register, formulate the problem, and wait in a queue for the solution to the problem. The matter is that there are small tasks, and there are larger ones. Some require 10 processors to solve them, while others need 100 such machines. They have to be loaded as close to 100% as possible. If solving a large task requires half of the processing power of the supercomputer, many nodes are needed. While we wait for the nodes to free up, some minor tasks can be solved. One of the things that we have developed quite significantly is queue management. We have original developments, which are based on prediction of the program execution time.
Значит, у нас тут оригинальные разработки, основанные на предсказании времени выполнения программы.
These programs not only help to execute orders faster, they also save a lot on energy consumption. According to scientists, when SCIT-4 was commissioned, it held the 100th position in the ranking of 500 of the most energy-efficient computers in the world. Most commonly, supercomputers are used by scientific and learning institutions, government agencies, and high-tech enterprises.
В силу прогресса всей этой вычислительной техники
Given the progressive computing technology over the last 15 years, the speed of accurate computational experiments grew higher than that of full-scale experiments in many other spheres. For example, no one would deny that building an aerodynamic wind tunnel to test a real aircraft takes a long time and is extremely expensive. It is better to create a mini project to test smaller models and then calculate the results for application in the testing of larger aircraft. The operation of ships is simulated in the same way, but there are machines that cannot be tested in such a unique way. For example, there is such a technique as modeling of behavior of the human brain. Some diseases, such as epilepsy and schizophrenia, are associated with synchronous electrical phenomena in the brain. Modeling techniques allow us to understand the conditions under which they occur and how to break that synchronization. That was one of the tasks for which a solution was found using this supercomputer. The SKID complex also processed some of the data from the Large Hadron Collider. Ukrainian physicists also took part in this common European research project, and they had the opportunity to use the processing power of their domestically made supercomputer. Supercomputers are for super tasks, but there are smaller-scale problems that should not be solved on such heavy-duty devices. At the same time, they are too complicated for a typical PC. For such cases, scholars of the Institute of Cybernetics, together with practical scientists at the Electromash Scientific Production Enterprise, both based in Kyiv, came up with a different system. The idea of the system belongs to the Institute of Cybernetics, while Electromash, where certain technical means have been deployed and certain components have been selected, served as its production site. Such means are typically used for reducing costs and ensuring high maintainability. Naturally, we could have used some exclusive expensive parts, but we had as our main goal to use more common, less sophisticated parts. Moreover, they also had to be designed to meet the technical requirements of around-the-clock operation, as they boast special technical features that guarantee such operation.
Можливості спеціальні, які цю роботу забезпечують.
Thus, a whole family of domestic IPCs appeared. IPC stands for Intellectual Parallel Computer. Why intellectual? Because when they receive a task, they analyze it themselves and then choose what algorithm, which devices, and which data transmission paths to go along. Then they generate a program for operation themselves. After solving the problem, they even check the accuracy of the results. They are parallel because the calculations are done on multiple computers at once.
Наприкінці 90-х років уже прийшли до висновку, що
Back in the late 90s, we came to the conclusion that it is no longer possible to create the performance of computers by the means of microelectronics technology. So we came up with the idea to organize a set of devices to solve complex problems and create such software that would allow for parallel, simultaneous processing of large amounts of data by multiple devices.
великих об'ємів даних.
The work on IPC began back in 2005, and now the next generation of those computers is already in operation. On the one hand, the SKID complex is to a certain extent a unique creation, and it cannot be replicated. An IPC, on the other hand, has the prospect of serial production, even though it is a complex high-tech product. Now it helps to solve mainly engineering problems. For example, in construction, engineers have learned to build structures higher than 500 meters. One can only imagine how many calculations are needed to create such giants. And that is exactly the job for computer systems like the IPC. And the software is written in such a way that specialists in their own field do not have to be a computer specialist or to learn how to work with it. The developers have made sure that the user experience would be simple and clear, and the program would start up with the press of a few buttons. After receiving a password, the IPC can be remotely accessed and provided with tasks.
Я могу вам продемонстрировать вживую на объекте.
I can demonstrate its work live on a very important object. This is a protective shell for nuclear power plants. The shell is a cylinder 1.2 meters thick, 100 meters high, and about 100 meters in diameter, and it is held together with very powerful ropes. The planner has prepared a sophisticated computer model with properties of the materials, geometry, and so on, which is divided into elements. I just launched it, and the Intercom gave me a message that it only has 256 cores in total and 8 cores that are currently available. So we select those 8 cores, and the processing on this supercomputer begins. We can see the protective shell on the screen and the number of algebraic equations that are instantly calculated. We received the results of calculations done on this Intercom supercomputer right on its working table. Just a few seconds to solve the problem, which would have taken a standard PC several hours to solve. And a person would have crunched numbers, built formulas, and looked for patterns for a very long time without the aid of computer technology. A couple of years ago, we had an order for a high-rise with 5 million variables, which means 5 million linear algebraic equations. Processing such amounts of data could take days for a computer-grade PC or laptop. The IPC processed the necessary results in a matter of a couple of hours. The IT industry in Ukraine has started to develop more actively in recent years. Ukrainian programmers are consistently in demand on the world market, and developers are coming up with ideas that surprise even the Western European experts. Therefore, it is not surprising that real supercomputers are born in this environment, and they are already solving super tasks, which will help Ukraine to rise to the level of superstates that are on the leading edge in the global IT industry.